Since ancient times, when there were no telescopes or spacecraft, humans have looked up at the night sky filled with wonder. Thousands of years ago, ancient civilizations like Egypt, Mesopotamia, and Greece were fascinated by those tiny points of light in the endless darkness. The ancient Egyptians built massive pyramids not only as tombs, but also to align them with constellations. The Babylonians mapped the movements of the moon and planets to predict seasons and human fate. The Greeks wondered, where does this universe come from? Are there any limits to it? In mythological stories, stars, moon, and sun were associated with all-powerful gods. This shows that from very early on, the universe was not just a place to gaze at, but an endless source of inspiration, driving curiosity and faith in things beyond human understanding. However, with the development of science, humans gradually realized the universe is not just a sparkling painting, but a massive mystery waiting to be decoded. We no longer just gaze, but began asking questions: how was the universe formed? Are we alone in this space? And can humans reach beyond Earth to set foot on distant planets? Today, when we have modern telescopes, space stations, and robot spacecraft tirelessly exploring Mars, that curiosity has never diminished. On the contrary, it's stronger than ever, because we understand that understanding the universe is understanding ourselves, our origins, our position, and perhaps even humanity's future. And all those questions begin with one great moment: the Big Bang, the event considered the beginning of space and time. To understand where the universe began, let's travel back in time more than 13.8 billion years ago. At that moment, everything we see today, from stars, planets, galaxies, to even tiny dust particles, did not yet exist. Instead, all the energy and matter of the universe were compressed into an extremely small point, called a singularity. Try to imagine this entire vast universe, hundreds of billions of galaxies, each containing hundreds of billions of stars, was packed into a point smaller than an atom. The temperature then was so hot that nothing could exist in a normal state. And then, in an unbelievable instant, that singularity exploded. Not an explosion in space, but the explosion of space itself. From the moment of the Big Bang, time began to flow, space began to expand, and the first particles of matter were formed. The universe then was like a gigantic fireball, extremely hot and dense, expanding at a terrifyingly fast speed. In a tiny fraction of the first second, it had expanded countless times beyond its original size, a phase that scientists call cosmic inflation. After a few minutes, when the temperature dropped, basic particles like protons and neutrons combined to form the nuclei of hydrogen and helium, the first two primordial elements in the universe. However, it took hundreds of thousands of years for the universe to cool enough for electrons to combine with nuclei, forming complete atoms. It was at that moment that the first light could escape, marking the time when the universe became transparent. And that light still exists today, in the form of cosmic microwave background radiation, direct evidence of the Big Bang event. The father of this idea was Georges Lemaître, a Belgian priest and astronomer. He dared to propose the primeval atom hypothesis in the 1920s, when most scientists still believed the universe was static and unchanging. Later, Edwin Hubble's discoveries about the expansion of the universe, along with evidence from cosmic background radiation in the 1960s, strengthened the Big Bang theory, making it the foundational theory of modern cosmology. In other words, the Big Bang was not just an explosion, but the moment that gave birth to everything: space, time, matter, energy, and even ourselves, small beings sitting here discussing it. When Georges Lemaître first proposed the idea that the universe began from a primeval atom, many scientists ridiculed it. In fact, the very term Big Bang was originally sarcasm used by astronomer Fred Hoyle to oppose this theory. But then, over the decades, science gradually found evidence that made the whole world admit the Big Bang is not just a bold hypothesis, but the truth about the universe's origin. First discovery. The universe is expanding. In 1929, Edwin Hubble, an astronomer at Mount Wilson Observatory, discovered something shocking. Light from distant galaxies was redshifted. This meant they were moving away from us. And not just a few galaxies, but all galaxies were expanding outward. In other words, the universe is not static, but expanding. If we rewind the tape of that expansion, everything would contract to an initial point, exactly the idea of the Big Bang. Second discovery, primordial elements. According to Big Bang theory, in the first few minutes after the explosion, the universe produced massive amounts of hydrogen, helium, and a little lithium. Billions of years later, when astronomers measured the chemical composition of distant stars and galaxies, they discovered that the ratio of these elements perfectly matched predictions from the Big Bang model. This is one of the strongest fingerprints of the theory. Third discovery, cosmic background radiation. But the most powerful evidence came from an accidental discovery. In 1965, two radio engineers, Arno Penzias and Robert Wilson, were working with a giant antenna in New Jersey when they detected a strange interference signal. They thought it was due to pigeon droppings on the antenna, but after cleaning it and the interference remained, they realized they had accidentally captured cosmic microwave background radiation, leftover light from the early universe. This discovery not only earned them the Nobel Prize in Physics, but also became the final nail in the coffin of theories opposing the Big Bang. Today, with modern space telescopes, scientists have created detailed maps of cosmic background radiation. The tiny, bright, dark spots in that radiation show the first seeds of galaxies, stars, and ultimately life itself. From an idea once ridiculed, the Big Bang has now become the pillar of cosmology. It not only explains the universe's expansion, elemental composition, and background radiation, but also opens a new perspective. Our universe is not eternal, but has a beginning and possibly an end. When talking about the Big Bang, most of us imagine it as the starting moment of the universe, a great explosion that created space, time, matter, and energy. But the big question is, was the Big Bang truly the absolute beginning, or just one chapter in the endless book of the universe? Scientists have debated this fiercely. Some believe that before the Big Bang, there was absolutely nothing. Space and time did not exist. The Big Bang was the 0-second mark of everything. However, many other hypotheses suggest that the Big Bang was just one event in an endless chain. There's the cyclic universe theory that the universe goes through countless cycles, expanding, then contracting, then exploding again into a new Big Bang. If true, then our Big Bang is just one of countless Big Bangs that have occurred and will occur. Other scientists propose the multiverse hypothesis. Our universe is just one bubble in the endless ocean of other universes. And who knows, the Big Bang might just be the collision between those bubbles. The problem is, we cannot directly observe before the Big Bang, because light, time, and space all began from there. Science can only speculate through mathematics, theoretical physics, and indirect clues. So, was the Big Bang really the beginning? The answer is, we don't know for sure. But this very mystery continues to drive humans to keep searching, keep questioning. After the Big Bang explosion, the universe was not immediately brilliant as it is today. Initially, it was just a chaotic sea of extremely hot and dense energy, where basic particles constantly collided and annihilated each other. About 1,000th of a second after the Big Bang, basic particles like protons, neutrons, and electrons appeared. The next few minutes, they bonded into the first nuclei of hydrogen, helium, and a little lithium, the primordial elemental framework of the universe. However, the universe was still shrouded in darkness, because light could not escape from the dense plasma sea. Only around 380,000 years after the Big Bang, when the temperature dropped low enough, did electrons combine with nuclei to form neutral atoms. This was the moment the first light was released, the cosmic microwave background radiation that we still observe today. The universe officially became transparent from here. But the universe still had no stars, no galaxies. It took hundreds of millions more years, under the influence of gravity, for giant hydrogen clouds to collapse, creating the first stars. These stars burned bright, then died in supernova explosions, scattering carbon, oxygen, iron, elements essential for later life. About 1 billion years after the Big Bang, the first galaxies appeared, connecting into the massive cosmic web we see today. It was a long journey, from absolute darkness to a sky full of stars. If the Big Bang was the beginning, where will the universe go? This is a question that makes scientists, philosophers, and even ordinary people like us constantly wonder. And so far, science has proposed several possible scenarios. The first scenario is the Big Freeze, cold death. The universe will continue expanding forever. Galaxies will drift further apart. Stars will gradually extinguish, leaving cold black holes. After trillions of years, the universe will become an endless dark region where temperature approaches absolute zero, with no life remaining. The second scenario is the Big Crunch, the Great Collapse. If the density of matter and energy is large enough, gravity could overcome expansion, pulling everything back together into a singularity like the starting point. The universe would end with a reverse bang, and who knows, a new Big Bang might give birth to another universe cycle. The third scenario is the Big Rip, the Great Tear. If dark energy, the mysterious force driving the universe's accelerated expansion, becomes increasingly stronger, it could tear apart all structures, from galaxies, stars, planets, even atoms. The universe would end in absolute disintegration. We don't know for sure which scenario will become reality, because there are still too many mysteries left unanswered. But whatever the outcome, one thing is certain. Humanity is still living in the great moment of cosmic history, between beginning and end. This was the first video from Space and Time, exploring the Big Bang explosion. Please like, share, and leave comments below to let us know what you want to explore next. And don't forget to subscribe to the channel so you don't miss exciting discoveries about the universe. Hello, and see you again.